What up, everybody? Welcome to another episode of Electrical Blunders. My name is Paul Abernathy, your host, and welcome to the show where in the Electrical Blunders, what we're doing is we're looking at videos that are available out in the public domain, have a considerable amount of views online, and people are watching these videos, and every now and then I get them sent to me, and then sometimes I find them. And in case of today's video, it was actually sent to me and asked if I would critique it. So we're going to look at it. But here's the thing. I'm not doing this to hurt anybody's feelings. I'm not doing this to make somebody feel like they're not as smart or I'm smarter. We're using this as a learning tool to help other people learn the code and learn electrical installations. And we're utilizing publicly available videos that have been out there, and people are learning from it. The problem is when there's misleading information, people learn the wrong way. And that's what we make an effort to try to set the record straight. Maybe teach the original publisher of the video a little bit and everybody else watching and learn a little bit as well. So again, this is our commentary on a publicly available video, and we're going to actually critique it and give some commentary to it. But remember, we're doing it for educational purposes only. We want to help people. Okay, so remember that. Now, if you like what you see, do me a favor. Give me a like, subscribe, and share it with somebody else. And if you really want to get a lot of private material, a lot of private videos and content on the NEC, or you want to really step your game up, go to this website right there, electricalcodeacademy.net, and you'll see we have courses on residential wiring, commercial wiring, grounding and bonding, industrial wiring. We have Electricity 101. It teaches you everything you want to know about electricity. We have grounding and bonding. And then we have our infamous fast tracks. Our Fast Tracks is without a doubt the premier product for learning the National Electrical Code. There is no better way to learn the NEC than with our Fast Tracks program. You get access to it for an entire year. You also get to join me on Wednesday nights where you can ask me questions live, one-on-one. We know you've been watching my videos for years. I've been doing this since all the way back in 2004. So look, this is your chance. If you want to join us, go to that website. We have a subscription for our monthly to get access to our private videos, or you can get our courses all from that website. So we hope you give it a look. All right, let's get started. I've got the headphones. I'm ready to get immersed into it with you, and we'll do our best at giving some commentary and maybe setting the record straight on a few things, okay? Now, I will tell you up front, these videos that I do this on, I haven't watched the entire video, only pieces of it to determine whether or not it's worthy. Because if it was somebody sent it to me and it didn't have anything wrong in it, then I wouldn't. But I'm calling these things as I go, and I'm making comments as I go. So let's look at it. All right, so here's our video. Let me get the headphones on and we'll get into this one. It's only 6 minutes long, so how long could it take to do this review? Okay, shouldn't take too long. All right, I'm ready to go. You ready to go? Let's all get it. I got my code book, 2020 NEC. Of course, we have it on the computer too, so I will point out anything that we need to point out. All right, let's do this.
Anthony from Inspectors Inc. We're at a residential home today, and I'm going to show you the typical things that we inspect when we do the electrical inspection. Okay, so for the electrical inspection, it starts with the service coming to the house. There's two types of service. It's either overhead, coming from the pole to the building, or it's underground, coming from the ground, coming up, and goes to the meter. Typically, the electric company is responsible for everything up to the meter. After the meter, it is the homeowner's responsibility.
Okay, so that is correct. So when you look at this meter, it potentially is fed down and over to a transformer. That's called a service lateral. If it was overhead, then it could be called a service drop to the service point, and that's the line of demarcation between where the utility leaves off and the electrician takes control. So in this case, the line of demarcation is at this meter, because now everything on the load side of this meter is the responsibility of the electrician. Everything on the line side of this meter is a service lateral, and that's under the rules for the utility. Their depth in the ground, all this type of stuff, that's on them, okay? But just so we set the record straight. Now, before I even get in further, I wanted to kind of briefly show you the different values that we would be working with. And again, I'm blocking some of it with this big old head here. But in this case, we're talking about a service lateral. in his. And what is a service lateral? Right here. It's the underground conductors between the utility electric supply system and the service point. And in our picture here, or the video, the service point is that meter. Okay. All right. So so here's what the service point is. It's the point of the connection between the facilities of the servicing utility and the premise wiring. It's that line of demarcation, as it says right here in this informational note. And remember, informational notes are just information, and they're good information. But that's all it is. It's not enforceable. And it's just kind of giving you an explanation. Right? Now, that service lateral again. Now, once it's overhead, it could be service entrance conductors overhead from an overhead system, or it could be service entrance conductors underground system, which would be under the purview of the NEC. If it's overhead from the utility to that service point, which is, say, that meter, then that would be what's called service drop. Okay. Now, be aware that for electricians, usually that line, that service point, it could be at the top of the mast. So we're going to be running from our meter up to the mast to a weatherhead, and then we're going to have that point where the electrician would size everything up to the weatherhead, but then from the service drop, which from the transformer or the serving utility point, down to that service point. Okay. So what is this? Again, we know what a service point is. It's the point between where the utility and the premise wiring lets off. Okay. Now, you only have one service to a building. Anything beyond that becomes feeders and branch circuits. But we have one service to a building, and that is supplied by the utility. Generators are feeders. Transformers that are maybe premise owned or tenant owned, that's all feeders. These are services. So some element of this is coming from the utility. Okay. So again, we're not going to get too deep in the definitions of it, but I just kind of wanted to throw that out there. In our example, the picture you see he's dealing with, that is probably a service utility because it goes from there to the transformer from the utility. So that's also the service point, okay, at the meter location in this case. All right, so let's get back to it.
So these are the components that we're checking, and it's the ones right after the meter. The most important one is the grounding rod or grounding system. They can either use a ground rod, which is into the...
You know, one thing I noticed real quick is I noticed that meter does not have a tag in it. So somebody could just come up, flip that up, pull the meter out. Now, I know if there's a little tag in there, somebody could also come and cut it. But in this case, there is no tag. So if I'm doing an inspection on the existing dwelling, by the way, just so you can know this, I'm going to wonder if somebody hadn't done an upgrade or a service or something without calling the utility. Typically, they're going to have a tag in there, and it seals it. Okay, and that way you know if anybody's tampered with it or not. I'm just saying. I just noticed that it's not one in there. Okay, never mind.
Ground and connected to the electrical system's grounding system, or they can connect it to a water line, assuming that the pipes in the house are metal.
All right, wait a minute. I was talking, so I didn't hear exactly what he said because we're going to have to clarify something. Let me move back a little bit and let me shut up and listen to what he says.
Ground and connected to the electrical system's...
Uh-oh, I got to go back further because he's talking electrical system. Hold on.
The meter. After the meter, it is the homeowner's responsibility. So these are the components that we're checking, and it's the ones right after the meter. The most important one is the grounding rod or grounding system. They can either use a ground rod, which is into the ground and connected to the electrical system's grounding system, or they can connect it to a water line, assuming that the pipes in the house are metal.
All right, let me stop him. And so this is where the information starts to get a little bit misleading, and it might just be because of how he's saying it. So the metal water piping that's in the building, that has to be bonded. Okay, that's a bonding requirement. If he's talking about the grounding electrode system and the water pipe, it has nothing to do with the metal piping inside. It has to do with whether or not it has metal piping outside that's in contact with the earth for at least 10 feet, and it qualifies as an electrode in accordance with 250.52A1. If it qualifies as a water pipe ground, okay. But if you have a water pipe ground, the way he states it, it can be this or that. That's not true. if you have a water pipe ground and it qualifies, it has to be supplemented with another type of electrode. And it can't be supplemented with another water pipe. It could be supplemented with additional ground rods, but it's not an or. So that's the first thing. Now, because the building has metal piping in it, that has nothing to do with whether or not it's a grounding electrode system. It has nothing to do with that, okay? So get that out of your mind. You have to bond the water piping inside of the building, but that has absolutely nothing to do with it. And yeah, the bonding of the water piping is 250-104A. That's the water piping bonding. That's in part 5 for bonding of Article 250. He's talking about electrodes. So in 250.50, it tells you have to have all the electrodes, you have to complete the system, and then it gives you these electrodes in 250.52, A1, A2, A3, A4, A5, A6, A7, A, and it's different types. Ground rods are just one type of electrode, right? But again, the water pipe ground has to qualify as an electrode, not just because the metal in the building, the piping system is metal. That means you got to bond it. But that ain't part of it being an electrode, okay? Just setting that record straight up front. So it's not an or, okay? Also, he said rod, not plural. In the National Electrical Code, and of course we're going to use the 2020 for this, because it could be older, but I'm just going to use the 2020. You have to have 2 ground rods unless you can prove that one of them meets 25 ohms or less. And you can't do that with a regular megameter. You're going to have to use a ground resistance meter or a 3-point fall of potential meter in order to determine that. Most electricians aren't going to do that. So they're going to put what? 2 ground rods in. Those ground rods have to be driven. If they hit rock, they can go at 45. If they hit rock again, then they can be laid in a trench. Okay. And all those rules are found up in the code. So point being is, they also would have 2 rods. They'd have to be at least 6 feet apart. The rods itself have to be 8 feet long, and generally they have to be driven. You have those other allowances, but you have to start out by trying to drive them. Okay, so I just wanted to lay that out there because, again, we started with some misleading information here, and I've given you a lot, and I don't want to confuse you. So I'll try to pause it and go on as we go a little further, but right now that's my observation, and let's see where he goes with this.
If they're not metal, it has to be a ground rod. And I'll show you what those look like.
Okay, so it doesn't have to be a ground rod, but the way he says it, if the pipes inside are not metal, then it's got to be a ground rod. And remember, it's got nothing to do with the metal piping in the building. You got to bond that metal piping if your water lines are metal. Got nothing to do with the grounding electrode system. So, and we're going to look at that in a second, but just want you to be aware.
The nice thing about this house is it actually has 2 grounding systems. It's not required to have both, but if one ever gets damaged or deteriorated, then you have the other system as a backup ground.
Again, I don't want to reiterate this. And he says that there's 2. You got to be, it says it doesn't require 2. If you have a water pipe ground electrode, then it does require you to supplement it. There is no ifs, ands, or but. If it's a water pipe ground. If it's ground rods alone, then that's all you need, right? If it's a U for ground, concrete case electrode ground, that's all you need. But if it's a water pipe ground and it qualifies as one, then you have to supplement it. I could supplement it with ground rods. I could supplement it with a UFR. I could supplement it with a pipe or plate electrodes. I have options. But the way he states it is incorrect. It's not an and or with this. If you do have a water pipe ground like he says, then you're going to have to supplement it. There's no way around that, okay?
That's a pretty good idea. So let me show you what some of the different types of grounds are. This one here is a ground rod. The ground rod is typically 6 feet into the ground.
Okay. It's not 6 feet into the ground. Okay. And we're going to go look at the code so I can show you this. Right. Now, incidentally, this is above ground so it's an impalement hazard. That connector could also, that's an acorn clamp, that could also be damaged, things like that. But anyway, we're going to go to code. I want to go to the code. And we're going to look in the area of 250 to kind of look at some of these rules real quick. So I want to make sure that we're all square on these rules. And I'm going to capture a lot here, so stick with me here. Again, bear with me. I know I have a tendency to give you a lot of information in a video, so stick with me. Remember everything that we talked about. So here's your electrodes. Here's your metal underground water pipe. You have metal in-ground support structure. That's like an I-beam driven or encased in concrete for 10 feet. Probably not going to be on a dwelling, by the way. You have a concrete encased electrode. We have ground rings. We have rods and pipe electrodes, and he's talking about a ground rod. And we have other listed electrodes, which means that somebody creates one that's listed. It might have type you pour chemicals in it or whatnot. It's a certain style. If it's listed as electrode, you can use it. You have plate electrodes. Again, 2-foot square surface that's exposed to the exterior soil. Then you have a plate. There you go. That's an electrode. And of course, you have other local metal underground systems. You could have a well system, other piping systems, underground metal tank. Again, that is in contact with the earth. Okay. So you have these other options. Hardly ever see these used. But what we do see common is ground rods. So in this case, he says he has a water pipe in this case. Now, notice he said his interior. What does it say about a water pipe ground? It says the metal underground water piping in direct contact with the earth for 10 feet or more. Okay. So the inside the building has nothing to do with it at all. It's got to be outside. It's got to be in contact with the earth. And maybe he does have that and he's just a little confused. I don't know. But the way he says it, he says that you don't have to have both. If you've got a metal underground water pipe, you have to have something else, one of these other ones. And where does it say that? Just so you know. But people ask me, they say, prove it, Paul. Right here. If you do have a metal underground water pipe, it says right here, a metal underground water pipe shall be supplemented by an additional electrode of the type specified in 250.52A2 through A8. And that is all of these that you see here. Plates, rings, rounds, concrete case, metal in-ground support. Those can supplement the water line. Because if the water line corrodes away or something happens, they come later and replace it with PVC, then you've lost your grounding electrode. You have to have one that's going to remain intact. So that's why it has to underground water line type of electrode has got to be supplemented. Okay, we got that straight? All right. The next thing we're talking about is the ground rods. So here's the ground rod. It says ground rod electrodes shall be not less than 8 feet in length. Okay, so it's got to be 8 feet in length, not 6 feet. And when it talks about the installation, this is where you see the installation requirements in 250.53 that tells you the ground rod, it gives you the applications under 250.53, how it's to be installed, whether or not you have to actually supplement a ground rod or pipe or plate. But did you know that? Okay. And of course, the requirements for putting it in the ground, like I told you earlier, it has to be installed so it's at least 8 feet in contact with the soil. It shall be driven to the depth of not less than 8 feet, except that where rock is encountered, the electrode shall be driven at an oblique angle, not to exceed 45 degrees, so at an angle, from the vertical, or where rock bottom is encountered at an angle of 45 degrees, you have a third option. The electrode shall be permitted to be buried in a trench that is at least 30 inches deep, 2.5 feet. Okay? So, look, these things are really important. So telling people the ground rod only has to be 6 feet, that's not true. Now, let's talk about when he said ground rod. What about the fact that you have to supplement it? So check this out. It says a single rod, pipe, or plate electrode shall be supplemented by an additional electrode of the type specified in 250.52A2 through A8. So I could have one rod and supplement it with another rod, or one of the other types of electrodes if I want. It's too much trouble. If you're going to put one rod in, you're going to put another in. And it says the supplemental electrode shall be permitted to be bonded to one of the following. So you go from that supplemental rod to options. You have options here. Now, this is basically telling me that if I have a single rod, I have to have another electrode. Well, this is saying, look, there is an exception. The exception says, hey, by the way, that single rod, pipe, or plate, if it has a resistance to earth of 25 ohms or less, and no, you cannot use a normal ohm meter. It's got to be a ground resistance type meter, and they're not cheap, but the 3-point fall of potentials aren't that expensive, but you have to have at least 50 feet to do the test. But anyway, if you do the test and it comes back 25 ohms or less, then I don't have to supplement that single rod pipe or plate. I can use just the one. So even though my ground rods would be supplementing, in his case, his ground rods, he says is in addition to his water pipe ground, he would need 2 of them, unless he can show me that one of them meets 25 ohms or less. Even though they're supplemental to the water pipe, you still have to meet the rules and the requirements for ground rods. Still got to meet it. Okay? All right. So anyway, so with all that covered and everything, we already know, and the chances are, again, it has nothing to do with the metal water piping system in the building. Now, where does that come in? People ask, well, where does it say, Paul, I got to bond all that? All right, just while we're here, might as well make the statement and show it to you while I'm here, get it over with. If you go into the code and you go to 250.104A, you'll see metal water piping. So bonding of piping systems. So in our case here, it says the metal water piping system shall be bonded as required in 250.104A1, A2, and A3. Okay? So you have different situations. You have the general requirement, then you have buildings that have multiple occupancies in it, and then of course you have buildings that are supplied by feeders and branch circuits. And so the method of how you do it is a little different for each one of them. But in this case right here, it's telling you you have to bond the water pipe if it's metal. So here it says the metal water piping system installed in or attached to a building or structure shall be bonded to any of the following. So you've got some options which you're going to go from that water pipe system to what? Service equipment enclosure, grounding conductor at the service, grounding electroconductor if it's size sufficient, and then or one or more of the grounding electrodes used if the grounding electroconductor or bonding jumper for those ground rods, let's say, or those grounding electrodes is of sufficient size. So they sized it properly. You've got multiple options. The point is here, you're bonding the water line inside if it's metal. It's not part of the grounding electrode system. In fact, that stops, the termination to it stops within the 5 foot of point of entry. So everything else in the building, the metal water piping, it's just metal water piping. Has nothing to do with the grounding of the system. So he gave you a lot of information up front that was wrong. So we want to make sure that we clear all that up for you as we move through that. Okay, so hopefully I made it clear in the amount of time frame that we've got to try to show you here. All right, so let's get back to the video here.
And only a little bit of it sticks up, and they have
none should stick up,
and it is fastened directly to the ground rod. The other one we talked about is when the electrical ground is connected to metal piping, assuming the house has metal piping. So let's take a look at that.
Again, has nothing to do with the house having metal piping inside. Okay, nothing to do with that. And I am quite shocked here that there is no water meter here. So it must be a water meter on the inside, whatever. Otherwise, they get free water. But anyway, here it shows it going down into the ground. So there might be a water pipe ground in this building. So he might be accurate with the water pipe ground, but it's got nothing to do with the metal in the building, as we've covered. I'm redundant. I've always been redundant. Sorry. But if that water pipe ground here, if this pipe is in contact with the earth for 10 feet or more, then it's going to qualify as an electrode. And of course, it still had to be supplemented, so that's why you have ground rods. It needs 2 of them, unless, again, they can show you 25 ohms or less. That would be the supplemental. The way he said at the beginning, you could have this or that. That's not the case here, so don't get confused with that.
Okay, so this is the copper pipe coming into the house, and if you'll notice, there's the ground wire.
Be honest with you, that doesn't look like copper to me. I'm just saying. Doesn't look like copper, but here we go.
Okay, and it's clamped directly to the
Maybe.
pipe. We do check to make sure that these ground clamps are nice and snug, because if they're not snug, guess what? No ground. Okay, so after the meter, the power source goes into a distribution box, also called an electrical panel. The main electrical panel consists of
I gotta say right now, I'm not too enthused about the sticker that's on that panel, but that's just a personal thing, and we'll move on beyond that.
main disconnect or main shutoff, and then the branch circuits, which each have their own individual circuit breaker. The reason you want a main disconnect is because you want one movement to shut off all the electricity to the house should there be a problem or electrical problem within the house. That's the best way to do it.
Also remember that that's required by the National Electrical Code in 230.70A1 as well. Outside or nearest point of entry, you have to have the disconnecting means to be able to shut it down. And remember that main breaker, that is short circuit, ground fault, and overload protection. Everything on the load side. The only protection it has for the conductors upstream through that meter and everything, the only protection that offers is from overload, because obviously that breaker has an amp rating and it's going to limit the amount of load. That's the only protection upstream. From that panel board, from that main breaker down, everything else, it's going to offer some load side protection. Obviously short circuit, ground fault, and overload, but nothing on the line side, only overload that is inherent to the rating of the device. Okay, just little things to remember.
Pull turns it all off. You can also turn these off individually, but that takes longer, and so that's the reason why we have the main disconnect.
It's not the reason, but
also the main disconnect is rated for an amperage. Amperage is the maximum amount of electricity that this house can use. In this particular case, it's 200 amps, and that's sufficient to run the house, the swimming pool, and a spa. If there was overcurrent, meaning the house was drawing too much electricity for any reason at all, the main breaker would shut off by itself without tripping the individual breakers.
Now, let me say something about that just so I can say it out there. If you have a situation where none of those individual breakers tripped, but that main breaker tripped, then that tells me that you did a very poor load calculation. I'm just saying. Because if you're not exceeding the ratings of these individual circuits and they're not tripping their overcurrent device, but you're blowing a main, then somebody did not do a calculation. And the reason I bring that up is because he says it does a pool, spa, the house itself, and I just want to let people know we do load calculations to determine whether or not that 200 is adequate or not. It's all based on a load calc. Article 220 of the NEC, Part 3 and Part 4, Part 3 being a standard method, Part 4 being an optional method. We have to understand it. If you don't know how to do load calculations, you need to get in my Fast Tracks program, because I will break it down and we will hammer it home how to do load calculations so you never have to worry whether or not the service is adequate or not. You know how to do the calculations. So if you want to get into our program, get into our program and learn the NEC. But you're going to learn way more than that. Trust me. I'm going to walk you through it. I'm going to mentor you. You're going to attend Wednesday night sessions with me. You're going to learn the code. You're going to learn electricity too, but you're going to learn the code. So anyway, let's get back into it.
However, if you have one appliance, for instance, the stove is malfunctioning and it's using up too much electricity, instead of it causing a fire, it'll trip the breaker individually. So, and you look at that, you'll notice that they'll have a little red spot on them in the window glass.
Remember now, not all breakers have that sight glass. All right, that's very unique for like Square D, Schneider, Cutler Hammer might not have it. Siemens might not have it. So very specific to Square D. And that looks like it's probably a Square D panel. Just remember, don't always go in there looking for the little sight glass to see it, because some manufacturers don't have that. Just kind of something to think about.
If they've tripped, the way you reset them is to turn it completely off and then turn it back on. However, if it trips again, you know you got a problem, you need to call a licensed electrician. Yeah, one of the things when we tell people before we take this panel off is you don't ever want to touch anything inside that panel. It is energized and it is very dangerous, okay? So if you do take the panel, we recommend that nobody takes the panel off except a licensed electrician or someone trained to do so, like a home inspector, okay?
I'll buy that.
So the way this is laid out is you have your main feeds coming in, and they're either made from copper or aluminum. And in the report, we'll describe what they are, what type they are, the main disconnect, the size of the capacity, which in this case is 200 amps. And we're also going to take a look at each individual circuit breaker. What we're looking for is we're looking for the size of the breaker and then the size of each individual wire. If you'll notice, these wires are quite a bit thicker than these wires here. This is a 30 amp breaker.
By the way, that humming and fuzz that you hear, that's on that video. It's not my video. Just so you know, I don't want any comments about, Paul, you had crappy audio this time. It's not my audio, by the way. So just so you know.
And this is a 15 amp breaker, and you can see the wires are quite a bit thinner. So we want to make sure they match. You don't want to have a 30 amp breaker with a 10 or 15 amp wire, because it will overheat the wire, and that's a fire hazard. So
okay, so let me make a comment about that. So this doesn't confuse people. You might have a situation where you have an outside air conditioning unit, condensing unit, and it has a nameplate. And the nameplate might say on it, minimum circuit ampacity, maximum overcurrent protection, whether it's a fuse or circuit breaker. So it might say 40 amp maximum overcurrent protection, minimum 20 amps branch circuit conductors. So that means that we're putting a 12 gauge, which is good for 20 amps, onto a 40 amp overcurrent device. The conventional logic would say you don't do that. Small conductor rules in 240.4d say you don't do that. However, there is an allowance in the code for doing that. So the reason I bring this up is because if you go blindly in there and say, okay, 14's going to 15, 30's going to 10 goes on to 30, 12's going to 20, yeah, for general applications, that's absolutely correct. But there are allowances, and you have to be very aware of that before you call it out, whether it's to something like a motor or it's to something like a outdoor air conditioning unit or air handling unit or something like that. And where do we get that? I just want to show you. So we're going to go to the code really quickly for this one. And I just wanted to show you that because people do cringe when it comes to those things sometimes for overcurrent protection. So I just wanted to show you. So here's your small conductor rules right here. See, it says small conductor. All right. Now it says unless specifically permitted in 240.4e or G, okay, unless it's permitted there, it says the overcurrent protection shall not exceed that required by D1 through D7 after any correction factors for ambient temperature and the number of conductors have been applied. Okay, so the overcurrent shall not exceed, not exceed that required by D1 through D7 after any corrections or adjustments take place. All right, and again, we're not looking at E and G yet. So for, let's say that 12 wire that we're talking about, copper, it's a 20 amp device. So a 12 gauge has to be protected with a 20 amp. So these are your small conductors. These are general rules. Under the ampacity tables in the National Electrical Code, under 31016, you're going to see asterisks that say, remember these small conductor rules. However, the allowances in E and G, E being for tap conductors, and the whole concept about tap conductors is the conductors that are tapping to, let's say, the circuit, like a branch circuit, or the ones that tap to a feeder, they're typically going to be smaller anyway. So there's some allowances there, the tap rules. And if you don't know what tap rules are, again, get in our Fast Tracks program. We discuss everything about 240.21 and understanding tap rules. But the one that we want to look at is G. G is for specific conductor applications. So that outside air conditioning unit, covered in 440, parts 3 and parts 4, talks about those conductors and the sizing, and it makes it okay. So ultimately, it's okay to have a 12 gauge on a 40 amp device if you're using 240.4G and following the rules in the article that it references. Now, why is that? Well, the reason for that is because when the motor or the compressor starts up, you have this sudden surge. But then it's going to come down to its running amps, and it's going to be fine, and it's well within the scope of the conductors that it recommends. The overcurrent device is going to be able to handle that inrush that takes place. That's why it's higher. But it's still going to be more than adequate to be able to handle the needs of short circuit, ground fault, and overload protection. Okay? So overcurrent protection is short circuit, ground fault, and overload. That ultimately ends up being what we call overcurrent. All of them result in more current than what was originally designed for the conductor or the system. But it's okay under these applications. So you see it's okay for the AC and refrigeration. You see that it's okay in certain applications for the motors. You see that it's okay in part 2 of 422, which deals with appliances. These are motor operated appliance circuit conductors. So you do have some allowances here. So the point I'm trying to make is don't go blindly looking at a 14 and say that's got to be on a 15 amp. If you look at the legend and the legend says it's an outside air conditioning unit, then it might be okay based on 240.4G. So just keep that in mind. So, generally your normal branch circuits and things like that, it holds true. A 14 on a 15, a 12 on a 20, 10 on a 30 holds true. But there are those allowances where, because of the characteristics of the motors involved or the units that are involved, it's okay to do that. So always keep that in the back of your mind, that is something. Okay. All right, let's get back to it.
So those are the things that we're checking for when we're inside the panel. The other thing we're checking for is a thing called double lugging, where they'll put 2 or more branch circuit wires into a breaker. Some breakers are designed for multiple wires, most of them are not. So we're going to check to make sure that they're properly installed. Okay, so the next thing in the electrical system that we check is the actual appliances, or the lights, the outlets, the switches. And one of the things I wanted to show you, this is a really neat device, this little trade secret. These you can get at most hardware stores. They're outlet testers. You want to get the one with the little button in there because it tests what's called GFI, ground fault circuit.
So it's actually GFCI rather than GFI. So it's ground fault circuit interrupter tester. Now, this is a test device. You should be testing your GFCIs for you in the field or your home. You should be just testing the test button on the device that's mounted in the receptacle outlet box. You should be hitting the test button. Now, these devices are great for home inspectors and things like that, but you got to be careful because these things can be fooled, okay? Such as bootleg grounds and things like that, where you have maybe somebody put a 3-prong receptacle in where they didn't have an equipment ground, which is a no-no unless you GFCI protect the circuit, or you run an independent equipment ground, which the code allows in 250.130. So you have some allowances. But what people sometimes do to get around it and fool these things is they'll take the neutral, which is there, and they will put a jumper over to the equipment ground. Since they both go back to the panel at the same location, it fools the little tester. And it will look like that it's wired correctly, okay? Or there's no open ground, okay? So they can get fooled. Now, there's more expensive things called a sure test that can actually identify that and say, no, I know what you're trying to do. But just be aware that these things are not fallible. They're great to determine things like reverse polarity and things like that. But again, these are test devices, not required to use them. If you test the GFCI with the test button and it functions, then it's considered functionable. It's fine. All right. These are in addition. So they're great to pick up. They don't cost nothing, a couple bucks, but check them out. But he's going to explain it, I hope.
Interrupter. Any outlet within 6 feet of water, or exterior outlets, or kitchens or bathrooms, again, within 6 feet of water, should be GFI protected.
Okay, let's make this statement here. So I hear this one a lot. The statement is any receptacle within 6 feet of water is required to be GFCI protected. Okay, look, in 210.8a, and since we're talking dwelling units, it gives you a list of what has to be GFCI protected, regardless of being within 6 feet of water. Now, there are some rules in there that say if you're within 6 feet of a sink, then it's going to be GFCI protection. But in a kitchen, all the countertop receptacles have to be GFCI protected. Unfinished basements or finished basements, they all have to be GFCI protected. Okay, so there's other rules. Receptacles serving the countertops in a bathroom, got to be GFCI protected. Now, just so happens that they're probably within 6 feet of the sink doesn't mean they're necessarily within 6 feet of water, but I guess they are. But that's not the genesis of GFCI requirements. Okay, so we'll go to the code real quick so you can see that in case you're not familiar with GFCI requirements. I just never like to see the statement about water only because there is a numerous other requirements. So here it is, 210.8a. And you'll notice that it's required in bathrooms. It's required in garages, accessory buildings, whatnot, outdoors, basements, kitchens. Again, we're talking the ones that serve the countertop, not the ones that would be around the walls, let's say in a nook area, only the ones in the kitchen. Unless those ones in the nook area were within 6 feet of the top inside edge of the sink, then they would be required to be GFCI protected. Incidentally, here, if I have a bathroom and a bedroom, and the receptacle is in the bedroom just around the corner from the bathroom, if it measures, as the crow flies, within 6 feet of the sink in the bathroom, guess what? It's going to need to have GFCI protection, even though it's in the bedroom. Okay, it's all about the measurement. Okay, and you're going to see how you measure it. That's up here in the requirements for the measurements right here. For the purpose of determining this section, the distance to receptacle shall be measured. The shortest path that a supply cord of an appliance connected to the receptacle would follow without piercing a floor, a wall, a ceiling, or a fixed barrier, or the shortest path without passing through a window. So it's basically as the crow flies, because that's how you would pull the cord. Get it? All right. So anyway, there's a lot more than just being associated with water here. But again, I wanted just to point that out so that you understand that. Okay. Back to the video.
The reason being is that it's so to protect any individual so they don't get shocked if the outlet malfunctions. The way to test that is you simply plug it in there and it lights up. In this case, it's telling me that it's properly wired. So you can check this on any outlet to see that it's properly wired. If it's not properly wired, it has a nice little code here which tells you what the little lights mean. So you can see that 2 yellow dots means that it's correct, and then any variation other than that. So it's a great little device to do your own check for you. Now the other neat thing is when you press the button over here, you can see that it will check for GFI. And there it is. This is a GFI outlet in a garage. It's wired to a couple of other outlets as well. And it has the reset button in there. And it did trip when it was tested. That means it is functioning properly. So it is supposed to shut the power off when we add a ground fault to it. So get yourself one of these testers if you want to check your outlets yourself. It's a great little way to do that, and it's very inexpensive. They're about $10.
All right, so here we go. We'll come back to me. All right, short little video, short little commentary. Issues, real big issues with the grounding. Hopefully he'll reach out. Maybe he'll get in my grounding and bonding course and learn a little bit more about grounding and bonding. It's great. I'd love to have you. But I thought, did a good job on the video. Feels very comfortable on camera. That's great. We just have to be careful when we're explaining things that are important, like grounding of a system. And we have to understand it. For example, if he has metal water piping in the building, you got to bond it. So we already saw that in the code. If you have a water pipe ground, you have to supplement it. It's not a this or that for this case. So things that he needed to learn a little bit, but hopefully you learned something as well. And again, I'll say it like I always said. If you want to truly learn the National Electrical Code better, go to this website. Get in our Fast Tracks program. You will learn the code from the very beginning, the history of the code, all the way up to hazardous locations. Also, our program has over 1,200 exam-style questions to test your knowledge. You don't get better at something unless you push yourself. You want to push yourself. Our program has that. There's a lot of videos. There's a lot of features. And if you want to learn how our Fast Tracks works, go to our website. At the top, you'll see the Fast Tracks exam prep. Remember, it's not just for exam prep, though. It's for learning the NEC. But you click on it, and we have some videos you can watch. It will explain the program. It will show you everything that's involved in it. And to me, it really is a cornerstone of where we're going with education. So I was excited not to just give you a book. I was excited not to just give you a webinar, but we give you immersive interaction. You have our courses. You have me. I will help tutor you along the way. You'll join me on Wednesday nights. If you want to learn residential or commercial, grounding and bonding, industrial, or electricity 101, we've got courses for you. So check us out at electricalcodeacademy.net. And hopefully you got something out of this episode of Electrical Blunders. Until next time, stay safe and God bless.